Good morning, everyone. It is March 28th. It is about 11:08 a.m. Pacific Standard Time. This is Quake Weather here. So we're following up on the forecast we put out several days ago. We put out a very concerning forecast, one that I did raise a lot of red flags over, considering the coronal holes and all the other forces involved. We discussed several areas, and while this area was not on the highest risk, we did call it out. This is a successful forecast. You can go back and watch the video, and I'll just bring the video up in a couple minutes so you guys can see. If I recall correctly, and we'll review this when we go over the live stream we did a few days ago, I believe my highest risk areas were Japan, I believe, Indonesia, Philippines area, and then over here in the Fiji-Tonga region. The big New Zealand quake was not in our location forecast, so even though it fell in the time window for what we call for 6 magnitude or higher quakes, that was technically a time forecast was successful, which we're almost always successful with that here at Quake Weather. For the past 13 years that I've been doing this, it's in the high 90 percentile when we call out a time frame where a 6 magnitude or higher is going to occur. It's pretty much almost always guaranteed to happen. It's, again, I would say 95%, if not higher. Location forecasting, as we always mention, as we like to keep it 100, and we like to keep it honest and real here. So location forecasting, a lot trickier. It's something that has to be monitored over time because there's a lot of variability and other things that change as the hours and the days go on. So, I don't monitor these as closely. I do have I have other things that I do in my life, so it's not something that I can keep up with and monitor constantly. So I hadn't been monitoring the last 2 days. I've been very, very busy, unfortunately. So we're going to go look at all the data and see if this is something, if there were any precursors or signals that we could have followed had we been monitoring more closely. But this area was called out. I did put it at a low to medium risk. Unfortunately, it was a much higher risk. But again, as the time went on, we probably, as we're going to dig into the data here, we could probably prove that it would have been, we would have switched it to a high risk area if we had been monitoring. But let's be sure here. So for those of you that didn't know, that want to catch up, there was a massive 7.7 magnitude earthquake in Myanmar. Burma, Burmese boxing, if you guys are familiar with it. I'm very familiar with the neighboring country of Thailand. I'm very much into martial arts, so I'm familiar with the culture in the area here. So this one bugs me. I mean, they all bug me. It's terrible when you see something of this magnitude hit an area or a country where they don't have as solid a building structures as they do in other first world countries. And I don't want to sit here and label them a third world country or anything like that. But when we have earthquakes this big in places like Afghanistan and Tajikistan and Iran, and maybe not Iran, but like in Tajikistan, Afghanistan, some areas of China. I mean, there's 5 magnitudes of China that have been deadly. There have been earthquakes in Afghanistan and Pakistan that have killed thousands of people that would have only done minor structural damage to those of us here in the United States. So when something like this happens in Myanmar, it's really devastating. And so I don't want to go too further into that. We want to focus on the data here, but I just want to put that out there that I'm very much aware of how devastating these earthquakes can be in areas like this, and our hearts and our thoughts and prayers and all that stuff go out to these people, because this right here, I'm just going to be frank, this fucking sucks. This is terrible. Anyways, so let's look at what we could have caught had we been paying attention, constant monitoring. So let's go to the newest earthquakes first, and we're going to zoom in on this area. So these are all the aftershocks. And if we go to the beginning here, and if you look, I'm going to switch let's do 4.5 magnitude or higher, 7 days. I want to go 7 days because that's only 24 hours. So get rid of this. Let's go down here a little bit. I just want to check. Sorry, I'm using two monitors, so if you see me clicking off screen, that's why that happens. So interesting. So it was just there was no pre-seismic. Wait, did I select past week? Yeah. Look at that. A lot of times, not always, but a lot of times we'll see events like this occur in the same little area all clustered up before we get an event like this, but we didn't this time. So pre-seismic signals as an indicator of a bigger event wasn't present. If we go to, let's see, what do we got here? Nope. Uh-oh. Another big watch coming in about a week or so. So let's go over here. See, this is why we called it out. We called out this area. These low pressure cells are much bigger than they were when we did our original live stream. That's why I only had this at a low or a medium risk area. I remember strictly calling out Myanmar because it's not an area that we call out very often. And I would say the low pressure cell area was much smaller than this. It was much smaller. I remember it was much bigger than it was over here in Iran, which doesn't have it anymore. And they did get a 5-pointer. But this low pressure cell, you have all these, I'll zoom in a little bit here. You have all these charged particles just flowing into this area, and they're just all hovering right there. So hold that thought. Just remember that we have this low pressure cell right here. And this is something we would have, because this low pressure cell grew significantly in size over the past couple of days. It definitely was not this big. I would have put this at a much higher risk had I seen this yesterday. But like I said, well, we're going to put a little thumbtack on this or whatever and just remember that. And then we're going to go over here to the OLR anomalies, because these are two things we correlate. Low pressure cells near plate boundaries, typically, with OLR anomalies. And if we go down here, let's just go down here to the daily. Where's the daily OLR anomaly? There it is. Let me make this full screen. So not much, but, well, let's see what the date was on this, because where did they put the date? So this was yesterday. And we look right in this area right here. I can't zoom in any further, unfortunately. We look right at this area right here. We see some strong positive confluence, like this orange area. So it wasn't like negative. That's basically what the colors kind of represent. If you have white, it's mostly neutral, but at times white just means missing data. Like this big white area right here, if you see it's kind of pixelated, that just means it's missing data. But and I really wish this is like the least inefficient satellite that we use for this data. I really wish it was better. I wish it was updated more often. Like, we're not going to get today's thing till tomorrow or even the day after. And it sucks because this is a very, very important, pertinent part of our forecasting method here. Our forecasting method relies on several different factors, multiple different satellites and models even that we use, data models. But again, this one's really important for location, and it's a shame that it's not updated more regularly or more precise. Anyway, so this was of positive polarity, and if you remember, if we go back to, okay, so that big coronal hole that we had, that's still facing Earth and it's turning away. See, as it's turning away, the forces from the most powerful part of the coronal hole are here. It takes about 2 to 3 days. Let's just say 3 days. I want to keep it simple. It takes about 3 days for a coronal hole that's directly facing Earth. It takes about 3 days from the unmitigated solar wind to come from the sun and arrive at Earth. So something that just starts facing Earth is not going to have its peak impact. It will have some effect, but it won't have its peak strongest impact until it's over here in this area. And what do we see right here? We see over in this area right here, 3 days ago, it was center. We can go back and look at this. 3 days ago, it was facing Earth. The biggest part of it was, this is a massive coronal hole, by the way. It's one of the largest I've seen ever, and it's definitely the largest I've seen in, I don't know, at least a couple of years. Sorry, I have to keep clearing my throat. I was yelling all morning at the gym, motivation, stuff like that. So yeah, the forces, the peak of the forces from this coronal hole started hitting, and that's what we see. We've seen this time and time and again. This is very much repeatable. You guys, anybody out there that you all these tools that I use, all these websites up here, all these links, and I'm pretty sure I have them in the description. These are all free resources. If you're in the anybody can access these. And you could start following along. I'm more than happy to teach anybody how to do this stuff. There's a number of things you have to learn, but it's not really that hard. The hardest part of the learning curve is just the time, because there's just little things. But if anybody ever has any questions or anything, I'm always more than happy. I love teaching people how to do this stuff. I love bestowing knowledge upon other people. I wish I had a massive team of people that could monitor this stuff. We could take turns. Like I can't monitor this stuff 24 hours a day. I have other things going on in my life. I do the best I can. I really do. There's especially fishermen. I got a lot of followers down in in the Southwest Pacific that they make their living off fishing, and they get tsunamis from quakes that happen deep in the ocean that they might not have felt on land. And I get a lot of those are my favorite people. They're really cool. They're really nice. They're very appreciative. They send me pictures of their family. They wish me happy holidays. I love it. Again, I don't make a dime from this. I don't make money off it. I feel amazing being able to help people, and at least, especially if you're a fisherman, and those people, they seem to appreciate it the most, because their livelihood depends on fishing. And I've been told this many times. I've never been down there, but from what I gather, it's just what it is that if you're a fisherman and you're deep sea fishing or whatever off the coast of a Pacific island in the Southwest Pacific, it would help if you go one day, if you're looking around going, yeah, I don't think there's going to be that much fish today. Is it worth going out there? And then if you have a seismic forecast that says, hey man, there's some rumblings going on, there's some blood echoes in the area, there might be a tsunami, they can safely say, hey, you know what? I'm just going to sit this one out today. And that has paid off in just priceless ways. Anyways, moving on. So this is the coronal hole. That's what did it. And this is around the time we should be peaking. If you remember the live stream, I believe I did it on Saturday. Actually, I think it was a Friday, actually. Almost a week ago. I called it out because of the size of this coronal hole, I had to increase the time length. Usually a coronal hole, it's only going to last 3 or 4, maybe 5 days. But I knew because of the size, especially the width and the strength of this coronal hole that we had, that this watch period was going to last at least a week. And it didn't start until a couple days after Friday. I remember I said it was going to start probably Monday, and then carry on into throughout the week. So, all right, enough of that. I don't want to ramble too much. So we didn't. Low pressure cells. This would have raised the risk right here. I'm not going to sit here and say for sure I would have called this out. I really don't know, but just looking at the data, I kind of think that I would. This is not the OLR anomaly I would like to look at. Let's see, this 7-day average. Not much going on there. You know what I mean? If 30-day averages, we don't really get a clear picture. The daily is what you want, but again, it's like when we have lagging, this is like what I call a lagging indicator when it comes to forecasting, unfortunately, because it's a very important one. Electron content, nothing interesting going on there. And yeah, so they got hit with a 7.7, and 12 minutes later, they got a 6.7. That's rough. I'm going to have to, at some point, let's see what kind of was this a populated area? I mean, some neighborhoods, a lot of farms and stuff. Let's see, let's go, where was this one? Yeah, I mean, this is not far away from a major city. Look at all that. That's terrible. I actually have friends training in Thailand. I have two, one of them's actually my Muay Thai coach. He's actually out there in Thailand right now. I believe they are in Phuket, if you're familiar. And yeah, I'll be hearing from them if they felt it. But yeah, I just wanted to pick up this live stream. So let's zoom out a little bit, because we did get some other We did get up some other notable events. We did talk about Alaska a little bit. Not too much going on over there. We definitely talked about Papua New Guinea. Papua New Guinea was definitely shaking up, and then obviously Japan. We called out this area. We were calling out. But things happen in this area a lot. You don't really deserve high fives for that. This was actually the area closest to that big New Zealand quake that we did call out. But technically, this is too far south of the area I was looking at, so we're not really going to count that as successful. But all of these, 100%. I mean, that's these all. Again, not above 6 magnitude, not really statistically relevant. The only statistical relevance is that we're seeing a larger frequency of events clustered up in this little area right here. And then I believe this happened the other day. This is right near that volcano, that the world's scariest volcano that nobody likes to talk about. And let's see what else we got going on here. Nothing major on the U.S. West Coast. That's good. We kind of called out this area a little bit. I put this on low to medium as well. And, this isn't too large, and it's not really out of the ordinary. This area gets earthquakes quite a bit. If just from my experience, if I were to call out the areas that have the most earthquakes, it is all these Southwest Pacific Island areas, like basically just this whole area right here. The Ring of Fire, which is basically the plate boundary that goes around the Pacific Ocean, they call it the Ring of Fire. Down here, from, in between New Zealand and then Fiji Tonga area over here to, Vanuatu and over to Papua New Guinea and Indonesia and sometimes Malaysia, but mostly Indonesia and the Philippines get rocked all the time, and South America. Those islands get it a lot. I did call out Easter Island, which is interesting because I'm actually pretty good at calling out Easter Island, and there's hardly ever large events that happen there, but usually when there is, I'm able to pinpoint it and get a good forecast about it out. Okay, so I'll just zoom back on this one more time. So they're still shaking over there. They're still getting 4 magnitudes and stuff. I haven't looked at the news. I haven't looked at the damage. That's something I need to look at, but I don't enjoy it, so I'm not going to lie. I've been kind of, I had a rough 2 days. The last 2 days, things started shaping up this morning, and then I heard about this, and when it rains, it pours, man. It's, heart goes out to all my Burmese boxing buddies. So what are we looking at now? If we go back over here, let's go to another thing that happened in the news. And you know what? Let me just generate a video for you guys real quick, because I want to show you what happened. I believe in the middle of the night last night. And let's do gold. And let's see if I can generate this slideshow real quick. So we're going to see, it wasn't facing Earth. It's nothing to be concerned about. A lot of missing data here, apparently. Well, that sucks. Anyways, I don't know if it's probably not going to show it. There was a massive X-class solar flare going off the left side of the sun over here. Again, I'm pretty sure that's not going to hit Earth, but it was huge. Let's see if we get it on here. You see things slowly see all that filament. That's terrible. Let me try another. Let's try my favorite 211 purple one. It's easier to see the coronal holes in 211 angstroms. So let's see if we get a better shot of the. See if we get a better shot of this. It is struggling. The internet is definitely struggled today. Sorry, I didn't mean to. So I don't know if this is working. Let me try. Can we do, let's do red. Not my favorite, but it works for solar flares. It's actually probably better than purple anyways. All right, let's see what it gives us. Nothing. That is very disappointing here. So yeah, I'll just try one more time here for you guys. Let's do do gold. I have a feeling if this one doesn't work, I don't know what to do. Okay, so let's see here. Did we do gold already? I thought we did bronze. Well, anyways, you see the filament cooking up right there, and then just before it probably is going to go black right here, we see the solar flare. Now, is the solar... Ooh, bam! You see that? That was... We are very lucky that was not facing Earth. I'm going to tell you that right now. I don't have the data on screen yet. I'll bring it up right now. But I want to look at this blast one more time. So massive. That was such a... This is one of the biggest solar flares. It's a very large solar flare. So you see all this filament collecting up here, right? And then all these coming, and then it just snaps. And you see the shock wave afterwards too. So let's go to, let's see here. Actually, no, we need solar wind. I don't have the bookmark for it right here. So let's do, let's go to NOAA. Solar wind predict. Actually, we could just look at this real quick because I'm sure they have some data on here already. Let's go ahead and play this and see how big it was on their annual spiral. And we're going to see it come off the side right here, right? Let's see. Is that it? No, that can't be it. There was definitely a bigger one, wasn't there? I mean, that's going to graze Earth, but what is this? Okay, you know what? I don't think they've updated this yet, so this probably isn't the best products and data. Where is the... Let's see. Look, yep, it was an X-class solar flare. So we got right up into the X-class, only an X1. That was still a large explosion. I would have thought it was actually a little bit higher than that. Yeah, no, that's pretty current. That's about what time it is. Actually, about let's see, what is that? 1820, and we are -7 right now. So yeah, no, that's only about, yeah, that's definitely it. And yeah, that was a big one. That was a big solar flare, my friends. So we're going to be getting the effects of that pretty soon. And then I'm going to have to do another live stream later, but we see this red area turning in right here. That's another coronal hole. And typically the negative polarity is stronger than the positive polarity, unfortunately. So it's an extension of the northern solar polar field due to where we're at in the solar cycle and the sun's magnetic, cycle flip or whatever you want to call it. So yeah, in a few days, probably in about 3 days, I'm going to have to do another forecast for this one. And hopefully it's not that big when it turns around and faces Earth, but we're going to have to wait and see. Another thing I want to do here is if we go to stereo A, where is stereo A? So let's first, is there a better one I can go to? If we go to stereo A, that basically that's a satellite that's about 30 degrees. If you're going by the circumference of our trajectory around the sun, like us circling the sun, it's about 30 degrees to the left. So stereo A, I think of it as stereo ahead. It's so whatever is facing the stereo A satellite. Yeah, this is it right here. Oh, here's the solar wind I wanted to look for. So yeah. There's that. That's a big phi angle shift. This is actually probably right when the earthquake occurred. Usually, when we get a large phi angle shift like that, that is also a trigger of large earthquakes and volcanoes. Where did I? No, it's the. If you go to ISWA, it stands for ISWA. It's the Integrated Space Weather Analysis, and it is not the Wrestling Association. That is weird. What happened to ISWA? There we go. Integrated Space Weather Analysis. This is where you want to go. I got some cool stuff here. So, let it load. I think my internet is going slow today. I'm getting like warnings on the screen here, on the stream. Sorry. So, Okay. Let's see. Where is... okay. I was typing there. Excuse me. Stereo ahead. See? Stereo A, stereo ahead, whatever you call it. Blue. I like the blue. It doesn't... God, this thing just doesn't update that often. So it's hard to say by looking at this. Can we go any further here? No. How about we stereo ahead? Let's try this one. Okay, there we go. This is from the 28th. So yeah, this is from today. This is from, let's see, a few hours ago. This is from 3 UTC time, which is about 8 o'clock a.m. our time. So if we look right here, this is so like Earth is a little over here off to the right. This area of the sun that's facing stereo A, this is what's going to be turning into Earth. So this big coronal hole right here, it looks like it might be a little wide. And again, by the time it is facing Earth or coming into view of the Solar Dynamics Observatory satellites that we always start off with, it could be either bigger or smaller. These things happen. We definitely see this is I don't that's a concerning sunspot area, but I think the area that flared, that gave off that X-class solar flare, might have been this little group of sunspots right here. And so solar flares and stuff like that, they do contribute to seismicity. It's an interesting discussion that I've had with some people in the seismic forecasting community, so to speak, at least the ones that are worth talking to, is that it's hard to say for sure whether or not each individual solar flare is going to either contribute to more seismicity or could actually act as a buffer. I think both are true. I think anybody that I spoke to says both can be true. And it's hard to say because what happens is we get this blast from the sun, right? Solar flare, CME, which is a coronal mass ejection, coming off the sun. We have all these charged particles, all this matter and plasma flying towards the Earth, right? It scoops up more charged particles along the way, which actually makes the impact a little more powerful. However, what happens is that not all of those charged particles actually penetrate through all the layers of the atmosphere and go down to the lithosphere to trigger quakes. Sometimes it seems, and again, I'm just using correct language here, sometimes it seems like it does. Like we see that, and it's like, no, we figured it was going to arrive, around today. And suddenly today we're seeing more smaller earthquakes, but we're also seeing larger magnitude earthquakes. That would lead you to believe that solar flares contribute to seismicity. However, we've also seen the opposite, where we're expecting like a coronal hole, we're expecting forces from a coronal hole in a day or two, and then we get a solar flare facing Earth on top of it, and then it's just like, oh, okay, so this is like kind of like a double up here. We're getting the unmitigated solar wind and forces from the coronal hole that's facing Earth, but at the same time, we're going to get these fast-moving, charged, really hot and dense charged particles coming off of CME that are going to couple with the unmitigated solar wind from the coronal hole and create a bigger quake. However, sometimes those forces, they rattle the upper layers of the atmosphere, like the magnetosphere and the ionosphere, so much that the energy transfer ends up taking place in those upper layers of the atmosphere. So instead of triggering a large earthquake, all those charged particles that we expected to trigger a large event end up doing other things, like causing more aurora, causing radio blackouts and stuff like that, and messing with airports and airlines and people with pacemakers and stuff like that. The closer you get to the polar regions of the Earth, the larger you are at the effect of this. Just throwing that out there too. If you have a pacemaker, or you really depend on your electronic equipment to stay alive and stay healthy, then you're going to have more and more problems the closer you get to the pole regions, like people in Canada or like northern Russia or I guess maybe Siberia or something like that. It's the closer you are to the equator, the more protection you have from the magnetosphere, which is Earth's magnetic shield. So get rid of these, get rid of that. So sometimes, anyways, point being that when we get a big solar flare, again, this one, if it does hit Earth, it's just going to be some, it's going to be a brushing sweep. We might get some aurora out of it. I know we got some spectacular aurora just a day or two ago. And the aurora is much easier to forecast. It's fun. If all I had to do was just forecast when we're going to see bright aurora, that would be awesome. And then I wouldn't have to sit here and think about all the terrible stuff that everyone here is going through right now, And it's a lot easier to be successful when it just, forecasting aurora is easy. Forecasting time window for earthquakes is, we've gotten it down pretty much almost 100% now for 6 magnitude or higher. And again, 6 magnitude is the standard here at Quake Weather. Forecasting anything less than a 6 magnitude is not a statistical relevance in terms of forecasting major events. We don't consider a 5 magnitude a major event. They happen too often. They happen almost every day. And you could pretty much throw a dart at a calendar and hit a day when a 5 magnitude is going to hit. The odds are actually in your favor if you want to do that. So 6 magnitude or higher, time window is really easy to forecast. Again, the location forecasting is much harder. I mean, that's when the accuracy goes from, at least on my end for the last 13 years or so, it goes down from, the 96th percentile or whatever of the time forecasting, the time window. The location forecasting is not, man. It's lower than that. Like, I'll usually put a list of areas out, and if I get one hit, then that's successful, right? But if the other places don't get hit with a major event, then you can't really count that as a success. I mean, it's a good forecast, still valuable, still helpful, and I still do it. This is why I do it all the time. I'm going to be wrong. I'm going to continue to be wrong until we get better tools, we get better satellites, we get better data. You know what I mean? The Chinese and the Italians are working on this. They got satellites up there. They're doing stuff that we aren't doing. But seismic forecasting is going to become a thing. There is definitely a science behind it. I've been using these tools, again, like I said, for about 13 years now. I've been publicly forecasting for at least a decade now. And yeah, location is not, I don't always nail it. You know what I mean? And every now and then I do miss one. This one, I should have leaned in heavier, but I did not see the updated data from the last few days because, again, I am doing other things in life and I just didn't have time, and which is unfortunate. But again, we're being honest here. I wouldn't have elevated the risk of this area too much higher. And if we look at the time scale of this, there were no pre-seismic events leading up to this at all. At least not above, let's do this. Let's be accurate here. There were no 4.5 magnitude or higher. So usually what I look at is, I'll go to a detailed one. If you go to search earthquake catalog here, you could put in custom, like how you want it. So let's do the past 7 days, but instead of, one of the defaults here, I'm going to put in a custom one here. So I normally do 4.0. So actually, I'm just going to stick with 4.0, right? Don't need to draw a rectangle. Let's just search. Just keep this simple. So let's go down here. And this was I think this was for the last 7 days, right? Okay, so newest first. Yeah, look at that. There was no precursor to this. At least there were other signals we were looking at. And like I said, I did call this out, but I called it out as a low risk area. And that's my bad. But yeah, hindsight is always 20/20. I'm very methodical with my forecasts, and with the information I had at that time, I wouldn't have put this on high risk. I just wouldn't have. That's why it's important to monitor these things. That's why I love teaching people how to do this. You know what I mean? It'd be great even if I just had 3 or 4 other people, we could just take turns. You know what I mean? I could just do it one day and then take a few days off and not have to look at it, and then 3 days come back, look at everything again, make sure everything's current and up to date, and just kind of like a relay race. I have not looked at any of this satellite data in the past 3 days. I made the forecast on Friday last week. I said all this week, and it's going to peak at the end of the week, and sure enough, it peaked at the end of the week. Again, valuable forecasting. Could be better, definitely could improve. I want to improve it, but I can't do it alone. If I didn't have to work, and I didn't have a family that I love to death, and I didn't have gym buddies that I help, that I train with, and so much other things going on. I just can't watch this constantly. An app, the idea of an app is out there. There is the best app out there. There actually is a really good one out there. It's called the Disaster Prediction app. Shout out to Nine Reese. He made that. He did a fantastic job. It is an awesome app. You could use that. That's definitely a cool thing to use. I don't use it that often, not because it's bad. It's a great app. It's just it's on my phone, and I'm almost 50 years old, guys, and I hate anything I can do on my computer instead of doing it on my phone. I'm going to do it on my computer. And I know how he collects all the data, but he has all the data, all the stuff in one place, and he uses computer vision and some other stuff. You got to pay for it. It's a paid app, but in my opinion, 100% worth it. If it's valuable to get these kinds of, and it's not just seismic, earthquake, volcano stuff. It's also all the magnetosphere stuff, magnetic pole flip. If you're into all that stuff, it's like it really is a great command center just to look at, have it everything all in one place. He did a fantastic job with that app. Anyways, moving on. Yeah, there were no pre-seismic signals. If we want to really get picky, see, this is why I don't stare at this stuff, because a lot of other seismic channels or earthquake channels, man, they just look at oh, there was a 2.5 magnitude there, but I'm not into that. That's not valuable. That doesn't help anybody, because there's literally 1,000 2-point magnitude earthquakes every day globally. That does nothing. You know what I mean? I live over here in California, and I have friends, and they go down suddenly they're getting paranoid, and there's all these fear porn channels on YouTube that are just constantly live streaming some earthquake map, showing you little 3-pointers here, little 2-pointers there. That's not doing anything for you. That's just scaring you. And it's just keeping you glued to your screen so people can collect a check. I am not about that. I don't get paid for this. I don't take payment from anybody for this. I do this to help. And so if we go to 7 days magnitude, 2.5, right? Let's see, 2.5 magnitude. See, if we go to all magnitudes, that's ridiculous. That's 2,000 earthquakes. But if we go to 2.5, we zoom back in on this area. Was there any kind of clustering of much smaller events occurring there? Nope. See, look at that. That right there is crazy. Because it's not 100% that when you see a cluster of small events as a signal to a much larger event. If we go back and we look at a lot of the major events, like 6, 7, 8 magnitude quakes, not always, but a lot of the time, usually, actually, I would say most of the time, there is some smaller earthquakes or rumblings that happen before it. That is actually a valid thing. It's not 100%, like I said, and we say that ad nauseum, but it happens enough that it is statistically valuable. It is statistically significant, and is something that we watch. And this is very unfortunate. They got a total rug pull here. And this this size in an area like that is really messed up. I would not have put this place on red alert. I just wouldn't have. Maybe if I saw the OLR anomalies, and if I saw this, if I saw all this yesterday, I probably would have called out this area. In Myanmar, where it happened, was down in this area. But if you see, all these charged particles are moving through here. But if you look closely here, all those charged particles are just coming off. They're branching off this system right here. They're off this system right there, wrapping around from that one right there. And then they're just hovering right there. You see how they're all just kind of meeting in that point? See, these low pressure cells, they could cause seismic activity if they're streaming through this area like they are right here. But this is actually, I don't know, just from looking at it, and this is just my opinion from looking at it, look at that. You see how low pressure from every direction, it's just all going right there to the center. That is a lot more concerning than seeing a large stream of it moving like this in a large area, because all this stuff is coming in there. Why is it just sitting there? Because it's meeting all this, the forces from this high pressure cell feeding into here. They're just meeting each other. So you picture, they're just getting like a double whammy from both directions. This is exactly why they had a large magnitude earthquake right there, right? Look at that. This is why we see that. This is exactly why this happened. There's more factors involved, but look at that. That's just that's almost right where it happened. That's almost right where it occurred. I mean, it's in geological terms, that is precisely where it happened. And again, if we had the ability to monitor this stuff 24 hours a day, or if I did, you know, maybe I'll get a team together or something. I should just do that because this is terrible. We could have, man, I don't know. But yeah, this is, you know, and then look, man, this is happening up here. But see, up here, if we look at where is this, if I can get it, kind of try to eyeball where this is. If we go over right here, see, there aren't any plate boundaries right here. See, these red lines are plate boundaries. When we get within, you know, like a 1,000-kilometer radius of these things, because they're actually massive. They go underneath the ground where the subduction zones extend all the way out to here. But that other low pressure cell area, look, it's happening right up here. Like I said, like if, where was it? Is it up here? Yeah, see how that little spot right there and up here, they're just flooding into that area and they're just hovering right there. So it's just like you're getting it from two different directions. And that's why you see those lines that are just streaming and they all just kind of stop. Those charged particles don't just disappear. They're collecting and clustering up and stacking up on top of each other and colliding with each other as, you know, other things are going on in the lithosphere, and that could trigger a large quake. However, it's so far away from this plate boundary here. And that's probably why you got this little one right here. I mean, there's no plate boundary anywhere near this area. Why did they get a 4.2? Well, if we go back and look, right? It's hard to say because this map, I wish it was different, but I'm almost willing to bet that area is like right here. I think actually it is. Is that right? Does that look about right to you guys? Oh, wait, hold on. Let's look at the... If we look at the rivers, we can kind of pinpoint. Yeah, kind of. But yeah, not near a plate boundary. So they got an earthquake where they probably almost never get one. And then in this area where they sometimes have small quakes, they got a massive one. And again, if we just zoom in on this area right here, that is exactly where this large earthquake occurred. And the reason, because it's not like 24 hours a day, 7 days a week, you're going to be on high risk when you see low pressure cells bunching up and all those charged particles bunching up in a spot near a plate boundary. It doesn't, like, I wouldn't raise it a red flag every day. However, what we're coupling these forces with is that there's an unusually high amount of charged particles in these low pressure cells because of all the unmitigated solar wind and all those extra charged particles that came from the sun, from this coronal hole, traveled down to Earth, and it flew into these high pressure cell areas like these gray and yellow areas, and then it came down into these low pressure cell areas. And that's basically like, just you want like a top level overview kind of summary of how we determine these things is we couple the low pressure cell areas, outgoing long wave radiation anomalies, OLR anomalies. So it's basically three things. If we start with the sun, we get electric charge. Let's just call them electroquakes and electric charge. We get charged particles from this coronal hole. 2 or 3 days later, we start looking at the low pressure cell areas that are near plate boundaries. That low pressure cell area is right by that plate boundary. Because in these plate boundary areas, what we also look for is the OLR anomalies. And again, this data is old, it's not up to date, but we look for the dark red and maybe even the dark brown. But look at these areas. See if I can bring that bigger. These areas right here are the most powerful, the red ones. And then we have these like real dark brown areas too to look at. So what these represent, these red areas, is where the largest concentration of charged particles that is actually emanating upward. There's charged particles that actually move upward from inside the Earth. They move much slower, and that's why they call it this long wave radiation. So, and when they say outgoing, that means it's actually coming up from the lithosphere, underneath our feet, coming to the surface, and then slowly going up into the air right above us. And that's why you have all this radiated outgoing long wave radiation, these slow moving charged particles coming from subduction zones and from, just the lithosphere itself, moving upward as we have these low pressure cells that are pulling in an unusually high amount of charged particles from the coronal holes of unmitigated solar wind. So those are basically, that's just to give you like a high level overview. That's kind of how we determine these things. Forces from the sun in the form of a coronal hole coming to Earth, those charged particles being dragged down closer to the Earth from high pressure cells down into low pressure cells. Low pressure cells, whether they're just streaming by or getting clustering up here, and the clustering up is worse, we would look just to have a trifecta of a strong signal. Then we would have an OLR anomaly, which is the charged particles moving upwards and then complete. If you think about it, it's kind of like completing I wouldn't say an electric circuit, but more like an electrostatic shock. And they're meeting together, and then that energy shoots downwards. It shapes the subduction zone, and inside the subduction zones, you have two things going on. Subduction zones actually have a lot of water, and sure all you guys know the relation between electricity and water. However, there's another thing down there. Let's see if I'm spelling this right. I know I'm spelling this wrong. So we have olivine. Olivine, if you don't know what olivine is, it's kind of a pretty green rock. It's not an emerald. However, there's an interesting characteristic about olivine. Olivine is in there's a ton of olivine in the subduction zone. And there's even guys on YouTube, I can't remember his name right off the bat. He does these electric, Billy's lab. Billy, I think it's Yelverton. He does some interesting tests with this, where olivine is an interesting material in the sense that it is similar to your teeth in that it creates an electric charge when you apply physical pressure to it. So, like if you apply a lot of pressure to olivine rocks disperse and bounce and move around with quite a bit of force. It's kind of like, if visually speaking, if you could just visualize, when you put the opposite fields of a magnet near each other, how they kind of repel, it kind of has the same force and the same effect. So there's a lot of olivine down there in the subduction zone. And that's actually what creates deep earthquakes, is that they're getting charged, they're getting hit with, they're piezoelectric. So when they get hit with pressure, they actually disperse more electrical charge. So anyways, I just think that's interesting. Olivine is an interesting substance. Shout out to Billy Elverton. He does some really good videos, illustrating and giving you a real good visual on how electric forces affect certain things, particularly, at least for my interest in seismic forecasting, the water and the olivine. Not a lot of people know about the olivine down there and the effect it has on seismicity. So I'm going to go ahead and wrap this up. This is a long one, but a lot of, this is, I told you guys I would follow up, and I'm following up. This is, again, I'm going to talk to my gym buddies. It's probably still the middle of the night over there, so probably not a good time to call yet, but I will call them this afternoon. I'm sure they're fine, but I have some other people that I kind of know that are in Myanmar, and I'm sure they're okay. And again, I haven't looked at the news or any of the damage or anything yet, but I'm going to have to. It's part of the deal, So how are we looking now? Actually, before we wrap this up, what are we looking at right now? So we're still, for the next 2 days, I would just say through the rest of the weekend, if you're on the U.S. West Coast like me, since we still got the left side of it directly facing Earth, still experiencing the forces from this. The magnetic connection with the interplanetary magnetic field of Earth and Sun is a lot sharper because of this. Those flux transfer events are going to be much more powerful, which is essentially where I think theoretically speaking, is where the actual trigger event happens. Flux transfer events, if you want to look that up, it's a really cool thing. There's like this, I'll do that. Actually, you know what? I'll make a video just about flux transfer events. I love the idea of flux transfer events. It's something that for some reason, I just think it's really cool. But anyways, not cool in terms of, seismicity here on Earth, but just the physics of it and just the thought of it happening. I don't know. I've always liked it. So I'd say through the weekend, I wouldn't say we're in the clear till about Monday. I think we can, but we're peaking right now. Just as I said I would when I put out this forecast a week ago. I said we would be peaking at the end of the week, and here we are at the end of the week. Nailed it. So at I wish I could be better at location forecasting. And again, man, I put this at low risk. I remember I called it out in the last live stream, or I maybe even just briefly mentioned it and probably just glazed over it. But there was no precursor. There was no pre-seismic events. Even if I was watching this closely, I don't think I would have got this one. So time period for sure. I knew there was going to be something very large happening by the end of the week. My forecast, and with the limited data that I had, I was putting the higher risk places at Philippines, Indonesia, and out here where we had this little cluster, because and very much so, because they were having these little clusters of events. Actually, I think I even remember calling out that area, or no, I think I remember calling out this area, actually. I have to go back and look, but a lot of stuff going on up here, which is kind of, unusual, but this far away from the fault lines. But yeah, so I would say we have a couple more days. If we go back and look at the wind maps here, I mean, obviously they're going to have some big shaking going on here still. Want to go look. I don't do Europe very often, but I would say there's probably more of a volcano risk. And if we do see any earthquakes in this area, especially in these island areas, it'll more than likely be due to underground volcanic activity. Because volcanoes and earthquakes are two different things, but the forces that trigger large volcanoes and earthquakes, or at least contribute to them in a very significant way, are kind of the same thing. So that's why I use the term seismic forecasting as opposed to just earthquake forecasting, because volcanoes are relevant too. There's been times where we've been able to kind of go, okay, this volcano is acting up, and then a couple days later we start seeing a big coronal hole develop, and we can go, okay, so this is probably going to contribute even more to that volcano. So if we do see any shaking here, especially in the island areas, I would say it's due to the volcanoes. But again, we're seeing this. We're seeing all these things. We're just seeing this like vortex, these low pressure cells right here. But this is like the big area of concern, I would say, at least in Europe. And we can go look at the Mid-Atlantic Ridge real quick. There was an earthquake down here, the Mid-Atlantic Ridge. It happens. I don't usually I don't put these areas on alert. Why? Because it's in the middle of the ocean and nobody cares. I don't think anybody felt this. If they do get a tsunami, I think the surfers will be happy and it'll do no damage. Not a big thing. Usually the Mid-Atlantic Ridge, we get them up here in Iceland a lot too. Excuse me. So let's go back and look at the OLR. So yeah, I would say, look, this area just south of Indonesia, but they get so many earthquakes down here that I kind of acts as a pressure. People say pressure release. I don't like to call it that because it's more of an electrical discharge release. Because they have so many smaller events, they get a lot of discharge. So like the chances of them getting like an 8 magnitude aren't as high as they would be if they weren't getting like all those smaller events, getting rid of that little bits of electrical discharge. Let's see, what else are we looking at here? Yep, that's that area in Europe. I would kind of keep an eye on this area in Europe. Japan, nothing really strong there, but again, this kills me. This is from yesterday. I really wish this was updated more often, or it's just tough. It's because this one, if I had real-time data is kind of a pipe dream, but if I had something closer to real-time data with this stuff, something that maybe got updated even just every 4 hours would be great, because this is, to me, is one of the more important tools for determining the location. We got the timing down stat. That is nothing. I mean, that's almost flawless. And for over a decade now, it's just, we got it. We got that down. The location forecasting is a challenge. It is much more of a challenge. I don't ascribe to the idea or the theory that events happen in a direction. Like, oh, we have one here, and since, the Earth is going this way or whatever, we're going to get another one down here and then another one down here. If you look at this stuff as often as I do, what you'll see is that one will happen up here, then one will happen down here, and then one will happen up here again, down here. Like it goes back and forth. Like when we zoom into an area, that has like a cluster, or even like a small cluster, or even like a larger cluster like this, what you're often going to see, way more often than not, you hardly ever see them all just going in one direction, like, oh, there was one here, and then an hour later one here, an hour later one here. No, I would say at least 75, 80, maybe even 90% of the time, most of the time, you get this one here, then you get one up here, but then you get this one here, and then you get this one there. And then does it zero into a center area? No, not really. I mean, kind of. Sometimes, you get one here, and then you get one way down here. Sometimes it kind of like, emanates outward from, the median point between two events. So again, like if you want to like do location forecasting, I would just look more for like the clusters. You know what I mean? You see a cluster right here. This isn't near a plate boundary. I don't know why this is happening in Texas. Sometimes I think they do fracking out there. Sometimes whenever you see like, I don't know about Kansas, but Oklahoma, there's like a ton of fracking out there. I remember there was a period of time where Oklahoma was getting earthquakes like all the time. And we just, found out it was because look how far away they are from plate boundaries. So, look, plate boundary here. they're getting a ton of them, but I bet you if we look at the low pressure cells in that area, oh wow, no low pressure cells yet, huh? Interesting. But they get a lot of they get a lot of tiny quakes out there, and again, they're just in these island areas that are these land masses that are barely protruding out of the ocean, and there's just like they're basically surrounded by this plate boundary right here. And then there's little fault lines that branch off of it too. But I would put them on somewhat maybe of an alert, not too high, but I don't want to, New Zealand still popping off down there. Look, yeah, that was a big one. But, this area, I would say Indonesia, Philippines, still kind of on the list. Let's look at their low pressure cell situation over there. I mean, it's dark here often, so it's kind of, like that. See right there, look at that. See how that low pressure cell is just culminating right there. It's just an amalgamation of this high pressure cell, these high pressure cells, these high pressure cells, and even contributing a little bit from over here. They're all just culminating in this area right here. Now that's not too far away. I mean, it's a decent area away from, a plate boundary, but not really that far, but if we couple that, if we go back here and look at the OLR anomalies, what do we see right there? I mean, this is how you correlate these things. Like we saw that those low pressure cells, like in these other areas and stuff, right? But I mean, it's not really too dark of an area as far as OLR anomalies go. But look at this one, it's just bright red. Bright red. It's almost. I mean, it's the center of this is probably a few hundred kilometers or a few hundred miles away from this low pressure cell. I mean, it's not. It's in the area. You know what I mean? And again, in the ocean. I don't know how populated it is right there, but I'm sure it's pretty populated. But they might even be having a storm right there. I don't know. So yeah, let's just zoom out one more time. So this area right here, I put them at risk a little bit for sure. Definitely put them at risk. They're going to have some big aftershocks. That northern area of Japan, if this coronal hole, if this low pressure cell right here gets any bigger, I would put, Japan back on the list. And not a super high risk, but I would put them up there. If we start seeing low pressure cells develop in California, because we are getting we get earthquakes in California all the time. I live here. It's just, this is where it is. I live in this area right here. So these earthquakes out here in Nevada aren't typically very common. I think over the past couple of years, we've been starting to see events in here in Nevada a little more frequently. Like it's usually pretty rare, but now they actually kind of get them like several times a year. We'll start seeing some shaking, some significant shaking. Let's just go to the fourth. Let's kind of clean this up a little bit. Yeah, I'm sticking with it. Basically the same forecast. Easter Island, Fiji, Tonga, Vanuatu area, maybe Papua New Guinea's. Actually, since they're not getting all that discharge, maybe. But mostly more here in this area. And then if we zoom out a little bit, I would still say Japan. It's like we still have 2 days of this coronal hole forces to go through. And I would still say Japan. And this area up here is not too many people live up here. This is technically Russia, I believe. Yeah, the Kuril Islands. I think that's Russia. That's where we see a lot more of that, the intensity, and kind of like, the center of it is just like up here out in the ocean. So that's not too bad. And, but, it could, move downward. This could actually grow in size, or another one could form. These things change over time. So I'll come back. I'll probably do another live stream tomorrow. And if we get another major event, as soon as I hear about it, I'll try to put up another live stream as soon as possible so we can go over it. But if not, what I'm going to do is I'm definitely sometime tomorrow, probably tomorrow morning Pacific time, I'll come back on here and just kind of follow up and see how much things have changed. So yeah, see if Japan's low pressure cell right there. Did they have an event right there? Yeah, look. See, it isn't a major event, but look, this just happened yesterday or last night. And actually, let's see, in Japan, I don't know what time it would have been in Japan. It might have even been today. But look, they got an event. It was almost a 5-pointer. And it's right there. It's low pressure cell. And again, this isn't 24/7. This doesn't mean you could just come to the mean sea level pressure map and just look at this low pressure cell and go, oh, okay, they're going to. No, there's a couple other things going on. And again, the trifecta for like the strongest positive signal of a major earthquake is the OLR anomaly, the coronal hole forces and how strong they are, and then the low pressure cells and how they're behaving and where they are. Where they are is very important. Remember, you want them to be, if you're forecasting, see, it's right near that plate boundary. So there's a lot of, my mind is blanking out right now. There's a lot of, we got the plate boundaries, and then we got, the fault zones and all that stuff that actually branch off of this. I'll go over that in another video and show you guys some cool tools so you can actually get a deeper visualization of all the fault lines. That's the word I was looking for. There we go. Fault lines. So yeah, we right there. Again, this isn't something to be, necessarily concerned about, but this is just to illustrate the point that like these would be more aptly named electroquakes. When you just say earthquakes, that implies that the earth just shakes on its own, and that's just what happens. And it's just like, that's not the complete story. That's not the whole story. So, if I had my way, I would prefer to call them electroquakes. I believe that a vast majority of these major earthquakes are electrical events. They are electrical discharge. They're, energy transfer occurring inside the lithosphere and triggering the subduction zones, the water, the olivine, and all that stuff that are in those subduction zones. So I think that's about it. Again, if another major event occurs and it seems like something we should go over, I will get home and get to my computer as quickly as I can. If not, sometime tomorrow morning, I'm going to do a follow-up video just in case, because like I said, we're peeking at it today clearly by the event that happened in Thailand, Myanmar. But, we're still experiencing a lot of strong forces for at least the next 2 days. I think it'll start to wind down, Monday. How much it winds down, I would just be guessing, but that's when I would say that's when I would confirm that we're out of peak risk time window. I think that's about it. Let you guys look at this solar flare a couple more times. And yeah, if you like what you see and you want to contribute to the channel, just like, comment, and subscribe. If you have any questions, more than happy to answer them. I'll talk to anybody. And I think that's about it. Stay safe. Quake weather out.